In the previous nugget, we talked about a few of the advanced features in a distributed switch, and in this nugget, I wanted to walk you through in the interface of where we would go to configure those, the relationship between a switch configuration and a port group configuration, and also provide a little more elaboration on a few of the features that are found in the distributed switch, which are not found in a standard switch. So to configure some of the advanced features that the distributed switch brings to us, we need to go in the vSphere web client over to the networking section. So we'll click on the networking tab. And with our distributed switch selected, let's go ahead and click on the configure tab. And then under settings, let's go ahead and click on topology. So here in the topology view, we have the distributed switch, which we named dswitch when we deployed it. We've got a distributed port group. We named it DSVM port group here. It's currently got 4 virtual machines associated with that distributed port group. And over here on the right, we have our uplink ports group. We named ours DS uplinks group. And we have 2 logical adapters, uplink 1 and uplink 2. And we can expand that uplink 1 to show us the physical resources, just like we can expand the virtual machines to see the names of the virtual machines. So if we expand those, the virtual machines shows us the 4 VMs that are associated with that port group. And if we expand uplink 1 and click on it, it's showing us the physical resources on ESXi 1, 2, and 3, which is VMNIC 5 on each of them. So in working with many of the advanced features that we mentioned in the previous nugget, regarding a distributed virtual switch, there's 3 common elements that we need to be aware of. Number 1, we have some elements that are going to be specific to the switch itself. So here, with the distributed switch selected and on the configure tab, we have these elements regarding settings that we can configure regarding the virtual switch. And a few of those are prerequisite to using features at the actual port group level. For example, if we want to create a new port group and have it participate as part of a private VLAN, that private VLAN has to exist first, so the port group can be a part of it. So for example, here at the switch level, we would go to private VLAN, create and set up the details for the private VLAN, and then when we work with our port groups, we can have our port groups participate as part of that private VLAN. And the similar is true for link aggregation control protocol. We would create our link aggregation group or groups, and then we would go back to our ESXi host and reconfigure them to tell them which VMNICs that they should use as part of those link aggregation groups. So with our distributed switch selected and on the configure tab, let's go through these options. Under settings, and if we click on properties, here's an overview of the current properties. If we click on edit, we can go ahead and modify those properties. So initially, when we created this distributed switch, we said we want to have 2 logical uplinks. If we wanted to change that, we could change it here. Currently, it's got 14 ports on this distributed switch. It's going to automatically grow that number as needed. And network I/O control is enabled because that's the way we set it when we created the distributed switch. On the left, if we click on advanced, here's where it gives us the option for setting the MTU if we are supporting jumbo frames, for example, in the 9,000 byte range. And one of the reasons we would do that is we have switches that are supporting jumbo frames. This is where we could set it for the distributed switch. For the discovery protocol, here's where we have the option of using Cisco's CDP if we're connected to a Cisco switch and want to do discovery, or we could use the industry standard link layer discovery protocol, LLDP. And for either of those, we have the option of listen, advertise, or both. So it depends on what physical switches we're connected to on the outside world. So if we didn't make any changes there, we can go ahead and click cancel. So our next option below properties is topology, which gives us the graphical representation. And from right here, if we want to edit the switch, we have an option here for edit the switch as well. It's a little icon of the switch with a pencil in front of it. We also have this option here, which allows us to manipulate which hosts are participating as part of the distributed switch, as well as migrating objects on the ESXi host over to the distributed switch, including VM kernel ports and VM network adapters. In fact, if we click on this icon right here, it brings up this wizard, the Add and Manage Hosts, which is also available. Let me click on Cancel, which is also available if we right-click on the distributed switch and we select Add and Manage Hosts. It's the same exact option. Just another way of getting there. All right, let's click on Cancel. Let me also bring Chrome into full screen. And if we wanted to create a new distributed port group for this distributed switch, we have a shortcut right here for that as well to create a new distributed port group. Our next category here under settings is link aggregation control protocol. This is a 2-step process. Number 1, we would create the link aggregation group, and then we would go back and reconfigure the ESXi hosts to assign physical adapters to that group. So it's really simple to do. We'll click on the plus symbol. So here are the defaults right out of the gate for the new link aggregation group. It's going to call it lag1, number of ports 2. We could, of course, modify either of those. The mode, passive or active. The key is we need to have one of the ends, either the physical switch or the ESXi host, be active. If both sides are passive, it's like going to a dance and having all the boys on one side and all the girls on the other, and none of them going across the floor to ask the other to dance. So the active party is going to be responsible for making that first step in negotiating and setting up the channel bonding, or the link aggregation control protocol group. So this would depend a little bit on what we're connected to on the outside. Here we have the load balancing mode, and we have lots and lots of options to choose from. If we scroll up, we can see the first in the list, and if we scroll to the bottom, we can see the end of the list. And the idea is that we want to make sure that we're not just sending all of our traffic outbound from the virtual switch out to the physical switch over one of our VM NICs. The goal is to make sure that we're sending traffic as fairly evenly as we can across multiple adapters, multiple physical VM NICs, as that traffic leaves the virtual switch and goes out to the physical world. So you can pick your poison here regarding your load balancing mode for that outbound traffic. And let's go ahead and click on OK, and we'll create this link aggregation group number 1. So we'll click on OK, and we'll click on the recent tasks just to verify that it's created, and it appears to be. However, it's not showing up here, so we'll simply do a refresh so that it shows up in the display. There it is. Now, to actually use this link aggregation group, we need to reconfigure our ESXi hosts to place, ideally, 2 adapters, 2 VM NICs, associated with this link aggregation group. So to do that, we could right-click on the distributed switch, and from the drop-down, click on Add and Manage Hosts. This is like the master menu to do virtually anything as far as reconfiguring either the VM kernel ports or the physical network adapters, or migrating VMs to or from the virtual switch. So because we've already added our 3 ESXi hosts and are currently using the distributed switch, all we want to do here is manage the host networking. So we'll click on that second radio button, click on Next. This list is empty. We want to populate it so we can actually modify the configuration. So if we click on the attached hosts link up here, it has a plus symbol. It's just really adding it to this list. If we click on attached hosts, it's going to show us all the hosts that are currently connected and using this distributed switch. And if we want to configure all of them, we put a check in each of their checkboxes, click on OK. And if we want to use one of these ESXi hosts as a template and then apply that same kind of configuration to the other ESXi hosts, we can put a check in the checkbox down here, configure identical network settings on multiple hosts, which is effectively template mode, using one of our ESXi hosts as a template, and we'll click on Next. Now it's asking us, which one do you want to be the template? And we're going to choose ESXi1 just because we can. Click on Next. If we wanted to migrate virtual machines, we put a check in that last box. We don't want to do that now. What we want to do is manage physical adapters. We want to assign some VM NICs to the link aggregation group that we just created. And for this step, we don't want to move any of our VM kernel adapters and their associated VM kernel ports to the distributed switch. So we'll remove the check from that second checkbox as well. So with the top one selected, we'll click on Next. Now it's asking us, okay, what do you want to do? And we're going to use ESXi1 as the example. So because I don't want to mess up any of our current networking that's in place, I'm going to go down, I'm going to grab VMNIC 3, which is not on any of our ESXi hosts being currently used for anything. And I'm going to assign VMNIC 3 over to the link aggregation group. So to do that, we'll click on VMNIC 3 and then click on this link here, Assign Uplink, that will assign that physical network interface card to the distributed switch. And then it's asking us, where do you want to put it? So currently on the distributed switch, we already have our VMNIC 5 associated with uplink 1. And if we wanted to associate VMNIC 3 with the first of the 2 ports associated with our link aggregation group, we simply click on lag1-0 and click OK. If we scroll up in the output here it's showing us that VMNIC 3 is about to be assigned to lag1-0 as part of the DS uplinks group. And then, if that's what we want to also happen on ESXi 2 and 3, we simply click on this link right here, Apply to All, which means apply the same thing we did to ESXi 1 to ESXi 2, which it did right here. And if we scroll down, it did the same thing for ESXi 3. And with that in place, we'll click on Next. Now, ideally, if we have a link aggregation group that needs 2 adapters, we'd want to have 2 adapters to assign to that group. Because using link aggregation control protocol with just one physical network interface card doesn't make any sense. Because there won't be any load balancing, there won't be any fault tolerance, there won't be any redundancy. So in a live environment, you'd want to have at least 2 ports, 2 physical ports, that are being used as part of a link aggregation group. So it did a check real quick just to make sure that we're not yanking out some VMNIC from some other required service like iSCSI storage access. And it says we're not. We'll click on Next. It's going to migrate 3 physical adapters, one from each of our ESXi hosts, to associate it with that first port in the link aggregation group on the distributed switch. So we'll click on Finish and click on Recent Tasks. And it is done. That update has been done on each of the ESXi hosts. Fantastic. So we'll minimize recent tasks. And if we wanted to delete this link aggregation group, guess what? It won't let us because we have 3 ESXi hosts that are currently using it. That's a good failsafe. So if we tried to delete it by clicking on the X and saying yes, if we look at the recent tasks, we have a nastygram that resource is in use. So if we wanted to go ahead and get rid of that link aggregation group, what we'd have to do is deassociate it. And that's not a bad thing to see. So let's right click on the distributed switch again. We'll go back to Add and Manage Hosts. From here, we just want to manage the host networking. So we'll click that second radio button, click on Next. We'll click on the attached host to give us the list of all the hosts. We'll go ahead and click on that top checkbox to select all of them. Click on OK. We'll go ahead and do the template option again to make it a little bit faster. Click on Next. We'll use ESXi1 as our example and click Next. So we're just going to manage the physical adapters one more time. So we'll use that top checkbox with a check in it. We'll leave the others blank and click on Next. And now what we want to do is take VMNIC3, which is currently associated with that link aggregation group, and with VMNIC3 highlighted, we'll click Unassign Adapter. So if we scroll down, we can see that VMNIC3 is now unassigned, or it will be when we commit all this. And then we'll click Apply to All to apply that same change to ESXi2 and ESXi3. Click on Next, and click on Finish. And now that we don't have any ESXi hosts with interfaces that are using that specific link aggregation group, we could go ahead and delete this group if we wanted to by clicking on the X, clicking on Yes, and that should delete it. So if we click on Recent Tasks, it shows us that the configuration is done. I still see it here in this display, so we'll click on Refresh here for vSphere Web Client just to make sure that it's completely gone. All right, next, under the switch, we have the private VLAN. And here's how they work. Logically, we've got a VLAN. So you can think of this entire space as a single IP address space. Let's say it's 192.16.40.0/24. So everybody who's going to be in that space is going to be part of that logical network. However, maybe we don't want everybody to be able to talk to everybody else. So what we do is we create what's referred to as a primary VLAN. And the primary VLAN is like going into a bar, and that primary VLAN will talk to anybody, maybe after a few drinks. So it's referred to as being promiscuous. So within this addressing space, the primary VLAN is going to have a number. Let's say that number is 10. So we have this primary VLAN called 10. And then what we do is we can create secondary VLANs. So let's imagine that this secondary VLAN is called 15 as far as the VLAN number, and this VLAN is 20. And this would also be a secondary VLAN. Now, not all secondary VLANs are created equal. Besides having different VLAN numbers, this one being 15, just an available VLAN number in our infrastructure, and this one being 20. Besides that, we also can specify the type of secondary VLAN that it is. And the two types are community, and the other type of a secondary VLAN is referred to as isolated. So imagine we have some hosts. Let's have VM, I'm just going to put host numbers here. VM1 in the top here in the primary VLAN. And let's say in the community VLAN we have VM2 and VM3. And over here in the isolated VLAN, let's say we have VMs 4 and 5. And here's how the game called private VLAN works. Every device in this private VLAN space can communicate with VM1 because VM1 is in the primary promiscuous VLAN, and it'll just talk to everybody. So everybody can communicate back and forth with VM1 because it's in the primary VLAN. So as we go down to this secondary VLAN, this community VLAN, these VMs can talk to each other. They can do it because they're in the same exact secondary community VLAN. And of course, they can also talk to VM1 because it's in the primary promiscuous VLAN. And then let's go over to VLAN 20, the secondary VLAN that's configured to be isolated. VM4 and VM5 cannot talk to each other because they're a part of an isolated VLAN. VMs 4 and 5 also cannot talk to any other community. They can't talk to VM2 or VM3. The only device that VM4 or VM5 could talk to is VM1 in the primary VLAN. And yet, all these devices would be in the same IP address space, but this gives us a way to help isolate pockets or groups of computers from not being able to talk directly with each other. And to put this all together, what we would do is we could create some additional VM port groups. And when we do create the VM port group, we could associate it with private VLANs and then specify which VLAN this port group is associated with. So we could have a port group associated with VLAN 10, we could have a port group associated with VLAN 15, and a port group associated with VLAN 20. And with those 3 different port groups, we simply assign the VMs to the respective port group on the distributed switch, and that enforces the rules of the private VLAN with who can talk to who. So to create a private VLAN, what we would do is simply, with private VLAN selected, click on Edit, click on Add, and let's say the primary VLAN is going to be VLAN 10. So we'll click on Add. We'll add a community VLAN, VLAN 15. We'll specify from the drop-down that this is a community secondary VLAN. And then we'll click Add, and we'll add VLAN 20. And from the drop-down for the VLAN type, we'll specify isolated. And poof, this creates that scenario that we just described a few moments ago. And then we'll click on OK. And then we can just create additional VM port groups. In fact, let's just create one real quick. We'll go to the D switch, right-click. On the drop-down, select Distributed Port Group. From the submenu, we'll select New Distributed Port Group. And let's call this pVLAN_primary. Click on Next. Here for the VLAN type, it's asking about the type of VLAN. We're going to specify it's a private VLAN. And then furthermore, it gives us the option of specifying, okay, what do you want? You want the promiscuous VLAN, the community, or the isolated? So we're going to go ahead and choose promiscuous. Click on Next. Click on Finish. Our private VLAN port group shows over here now on the left, and any VMs that we associate with that port group, guess what? They're going to be associated with that primary VLAN, the promiscuous VLAN, as part of our private VLAN configuration. Then we could have a separate port group for the community and a separate port group for the isolated to control the traffic. All right. Next on our list of settings for the switch, we have NetFlow. NetFlow is amazing, can give us a really great picture of what kinds of traffic are floating across our network. We're going to gather the information on those ports that are associated with NetFlow and then ship all that information off to a collector. And it's here where we would specify where that collector is. So for example, if we click on Edit and we have a NetFlow collector at 192.168.1.100, and let's say that collector port was 9998 or whatever it is, we could click on OK. So now if we enable any ports to grab information regarding NetFlow, the distributed switch knows who to send that information to, the collector at .100. Next, we have port mirroring. This is fantastic. If we want to collect the data, for example, from an uplink or from a port that a VM is connected to, this is a fantastic tool for taking that information from that port and shipping it over to somewhere where we can analyze it. And there are several options for port mirroring. Now in a Cisco environment, they refer to this as SPAN, which is an acronym for Switch Port Analyzer. And they've also got features like RSPAN, Remote Span. That's where you have one switch and you're collecting the data off of a port or a VLAN there, and then you're shipping it off to a second switch. So this would be switch 1 where we're getting the data, we're shipping it off to switch 2, and then off a certain port on that switch, we have the device that's collecting and analyzing all that information. So SPAN refers to a local switch where we collect and deliver it. RSPAN does it remotely. And effectively in a vSphere environment with a distributed switch, it can do all that as well. So this option right here is encapsulated remote mirroring, which you could think of as encapsulated remote span, because that's basically what it's doing. So if we wanted to do encapsulated remote mirroring, we could click on that radio button, click on Next. It's going to ask us about whether we want to enable it or disable it. So you could set it up ahead of time, then turn it on or off as needed. We can specify the encapsulation type. Generic routing encapsulation is the default. Then we can click on Next, and it's now asking us, okay, where do you want to collect the data from? So regarding the source, if we wanted to add specific ports, we can click on this icon here to add additional ports for the source. And it's currently showing us the ports that vSphere has assigned regarding this distributed switch for these 4 VMs. So if we wanted to capture data, for example, from VM2, we can click on port 6, click on OK, and continue. Or if we knew the port numbers, we could actually use this icon here and literally just put in the port numbers that we want to use as the source for this span session. So for this example, let me go ahead and let's choose port 6. That is the logical port ID that VM2 is using, and we'll click on OK. And then we'll click on Next to continue. Now it's asking, where do you want to send this? And we'll hit the plus symbol, and we'll put in 192.168.1.100. And what that would do, that would take all the traffic off that port, inbound and outbound. and encapsulate it in GRE and ship it over to this IP address. And hopefully at that IP address, we have something that's prepared to go ahead and de-encapsulate that and process that. So we'll click on OK. And if we have multiple destinations, we could add that as well. We'll click on Next, and then we'll click on Finish. And then below port mirroring, we have Health Check. It is quite possible that we make a mistake when we configure the connectivity between the physical network on the outside over to our distributed switch uplink ports. And if we want to enable the health check, we could click on Edit, and we could enable the health check for VLAN and MTU. We could also enable the health check for teaming and failover, and it is going to generate some additional traffic as it looks for errors. For example, maybe on the physical switch, they're not allowing VLANs 10, 11, 12, and 13. But on the vSphere switch, we're doing trunking, and we are allowing those VLANs. Those are the types of mismatches that the health check settings could assist us in discovering. So I'm going to click on Cancel. I don't want to actually enable those in the lab environment. So these are the settings of the switch itself. The last two sets I want to talk about are properties as they relate to port groups and properties as they relate to uplink groups. And then additionally, we can go down to individual ports on the distributed switch as part of a port group, for example, and then we can modify the policy on individual ports if we want to. So let's focus on our port group first on the left here, and we can do that by selecting the DSVM port group and then clicking on the Configure tab. And beneath Settings, with Properties selected, let's go ahead in the upper right hand corner and click Edit. So regarding this port group, over here on the left are all the options that we can set regarding it. So here we have the name of the port group. We have a static binding. Effectively, what that means is that once a VM has been assigned a port, a logical port, on that port group, it's not going to change. As far as allocating ports, it's elastic, which implies that if the switch has 28 new VMs that need to connect, it'll automatically create additional logical ports to allow them to connect up to its maximum. And when it's creating new ports, it's going to create them 8 at a time. So if it runs out of virtual ports, it'll create 8 more, and when those run out, it'll create 8 more, and so forth. Next on the list, we have Advanced. And on the Advanced button, it's specifying what we can change at the individual port level. So at the moment, we're configuring the port group. And also, by default, all of these options from this line going down, we don't have the ability to individually configure at the port level unless we allow it. It'll simply be grayed out for those individual options at the port. However, if we want to allow everything at the port level as well to override the settings that we currently have for the port group, we simply click on Allow for Everything, and that will allow the override at the individual port levels. Next, we have the Security tab. So these three options are very similar to the options that we have with the standard switch, except the defaults are different. With the standard switch, promiscuous mode was reject, but the MAC address changes and forged transmits were set to accept by default. And so if this is the distributed switch, and here's our VM on the left, and here's the physical network on the right with our uplinks. Regarding MAC address changes, that is traffic that is allowed to a MAC address other than the one that's configured for the VM itself. So for example, the guest operating system or utility changed it. The MAC address changes allows traffic to that VM that would be inbound to that VM. And the forged transmits allows layer 2 frames that have been modified regarding their source MAC address to be sent into the switch. So a couple of different terms for this would be inbound and outbound from the VM's perspective. However, if we started describing traffic in general from the switch's perspective, this would be considered egress traffic because it's going away from the distributed switch, and this would be considered ingress traffic because it's coming into the switch. So it depends on the context of what device we're talking about. And just to add a little icing on the cake here, if we use different terms from the VM's perspective, we could also say that this is ingress traffic because it's coming towards the VM. We could also say this is egress traffic because it's going away from the VM. So it just depends on the context of which device is the focal point. Now again, for these two right here, the MAC address changes and the forged transmits, that's from the VM's perspective. So it'd be traffic going to the VM and away from the VM regarding these two options. Next we have traffic shaping. And traffic shaping works very much like it did with a standard switch, except it goes both directions. The ingress versus the egress is from the perspective of the virtual distributed switch. So if this is our VM here and it's connected to port, for example, 5, and we have ingress traffic shaping, that is going to control traffic going from the VM into the virtual switch. And if we have egress traffic shaping, that is traffic going from the virtual switch, in this example, to the VM. And just as a note, On a standard switch, it supports traffic shaping, but it's only traffic from the VM into the switch. And in the documentation, it refers to this as outbound traffic. Don't shoot the messenger. It's outbound from their perspective of the VM as it sends traffic into the switch, which also could be considered to be ingress traffic from the switch's perspective as it comes into the switch. So for here, ingress and egress are based on the context of traffic as it relates to the switch itself. Our next option is VLAN. So if we want to go ahead and configure as part of an attribute of this VM port group VLAN tagging, we can do it. So for example, if we had some servers as virtual machines that supported trunking, for this port group, we could say we want to do VLAN trunking. We could specify the range of VLANs that we're expecting to see to and from those VMs. And then once this is an attribute of this port group, we simply assign those VMs, those servers that support trunking, to this port group on the distributed switch. So because we're actually modifying the properties of the DS VM port group, which we currently have VMs connected to, I am not going to specify that we're doing trunking from those VMs. I'm going to leave it as none. Or if we wanted to put those clients in a specific VLAN, we could choose the VLAN here. Or if we wanted to do a private VLAN, which we did previously with our other port group we created, we could specify private VLAN and then choose the VLAN that we want associated with this port group. So I'm going to go ahead and set this back to none. And then we have the option for teaming and failover, very similar to what we had with the standard switch with NIC teaming. Next, we have monitoring. This is where we would tell this port group that we want it to be part of NetFlow. So we could enable this port group for NetFlow. Next, we have traffic filtering and marking capabilities. So if we wanted to enable that feature, we could actually click on the plus symbol. We could create a rule, and then we could actually tag traffic. So for example, if we wanted to mark traffic with a DSCP value, for example, of 5, and we wanted to do that for traffic that was coming into the switch via this port group, then as that traffic gets further forwarded down the network, if we have our other network devices configured to look at markings in the traffic, for example, looking at DSCP markings, which we're setting here, or IP precedents, then those other network devices in the path could either prioritize or police or treat that traffic differently based on the markings we're applying to that traffic. And as far as rules go, we don't have to just tag traffic. We could also drop traffic if we don't want to see certain types of traffic. We could go ahead and specify ingress traffic if it matches, and then we could go ahead and put the qualifiers in for what would be a match. So these are typical of many of the features that we might find on a multi-layer switch in a commercial environment. So I'm going to go ahead and not set up any rules. I'll click on cancel because we are using that port group. And then under miscellaneous, we have the option of blocking all ports. Let's say, for example, there's a nasty virus that's spreading like wildfire, some type of malware, and we want to shut down everybody on a port group right now. This is how we could do it. Block all ports, say yes, click on OK, and boom, all the traffic on that port group comes to a halt. So I'm going to click on cancel. I'm not going to save any of those changes that we just went through. So this represents our port group. If we go to our uplinks group by clicking on it here in the navigator pane and clicking on configure and then clicking on edit, we have some options there as well. They're not quite as robust as our port groups for VMs, but we do have options on the uplinks, for example, regarding VLANs and monitoring. For example, if we want to enable NetFlow on an uplink, we could do that by enabling it for the uplink group. We also have traffic filtering and marking, just like we did on our port group. And then under miscellaneous, we also have the option of blocking all ports. And this would block all traffic over the VM NICs, over the uplinks to the outside world. So let's go ahead and click on cancel there. One last thing I'd like to share with you is that we can also override those policies on the individual ports. Currently right here it's showing the override port policies and it's all disabled. So let me just modify that one piece. So with the port group, we'll click on edit and let's go to advanced. And for override, let me go ahead and just enable a few of these. In fact, let me just enable all of them. And then click on OK. Now what we can do is we can go to individual ports and we can override the policy at the port group level with the policy at the individual port itself. So to do that, with the port group selected, we're going to click on the ports tab up here. Here it's listing all the ports. Let's go ahead and grab VM4, which happens to be on port 4, which is convenient just for numbering purposes. But we'll go to port 4 by selecting it, and then we'll click on the pencil icon to edit the port settings. So we'll click on edit, and from here, all of these attributes apply just to that port. So if we click on traffic shaping, if we want to override the port group policy, we'd click on override here and then specify the policy we want for that port. And now it's your opportunity to have some fun and practice as you work with and configure some of the advanced features of a distributed virtual switch. I hope this has been informative for you. and I'd like to thank you for viewing.